Hello, how are you? I hope you had a nice Easter or Passover. I just put out the homework 18. And homework 18 is to add two polynomials. And in this sense, I want it to overload the plus sign. Now, to do this, I'd like to show you a pretty standard algorithm that will help you do this, I hope. If you will remember, with polynomials, what we have is an array of terms. Each term has a coefficient and an exponent. And the array is ordered by exponent. So the largest exponent is in the 0th place, and then the next largest in the 1 place, and so on and so on. Now, you could think of that as a list ordered by the exponents. And what you're doing is taking those two lists and merging them together. For example, I'm going to do this problem instead, which is similar, but I don't want to do exactly what you're doing. I have two lists, and they're numbers, they're integers, and they're in order, from largest to smallest. And what I want to do when I finish is have one list that contains all these numbers and has no duplicates in it. Now, in your case, that's very similar with what you have to do. Where I say duplicates, you're looking at a term that has the same exponent in both terms that have the same exponent in both parts. Now, the trick is to be able to move down the two arrays. I sometimes call it take a walk down the two arrays. To take that walk, what I'm going to do is just keep a variable pointing to where I am. So, the variable in first has the value of the next index in first, and similarly for in second, and I'm going to have something called in combine also. Now I'm having some trouble here with the machine refusing to keep the paragraphs apart. There we are. All right. Think of it as you have two people walking down this list. They start off at the first place in the list, and each of them reports what they have. If they have the same value, then one of them gives you that value and the other one doesn't. If they have different values, the one with the largest value gives you the value. And whichever one, in the first case, both of them continue on. In the second case, only the person that gave you the value continues on. So let's look at this right now. I'm going to start with in first equals in second equals in combined equals 0. So what I got here is I am looking at first, in first, second in second. Compare the two. Well, the 50 is the larger one. So, copy first in first into combine in combine. Now, we have used up the first element in first. You might say we ate the first element in first, the 0 element in first. So we move in first to 1. Now we also ate the first element in combine. So we move in combine to 1. Now that means at this point we only changed one of the 2 pointers that go in the first and second. We have now in first equals 1, in second equals 0, and in combine equals 1. And combined is just 50 at this point. That's the only thing in there. Let's see, I think I can make just a little bit here. Now I'm going to copy these because I want to keep using them down below. So, what do we do next? Next, we do just what we did before. We compare first in first with second in second. Well, that's 30 and 40. So the 40 is larger. Now we copy second in second to combine in combine. We move in second and in combine. So now what we have in first equals 1. That didn't change. In second equals 1. And in combine equals 1. And combined equals 50 and 40. So we just keep moving. We do the same thing. Next, we compare the first in first and second in second. They are the same. Well, that means we only want one of them. So we copy either one into combine in combine. Now, I made a mistake here. This is now 2. There are 2 things in there. Now, let's look at this. What have we used? We ate both 30s. We finished them. So, we add 2 in first, in second, and in combine. And now what we're looking at is in first, it was 1, it's now 2. In second, was 1, it's now 2. And in combine is 3. And the list now is 50, 40, and 30. Okay, well, that's looking good. We're ready to go and do the same thing again. Compare as before. Compare this time the 25 and the 25. And guess what? They're the same. So, you'll have to excuse me. Somebody is asking for some attention. So, copy one of them into combine. All right. And now, let's see what I have to move. Well, it looks to me that I have to move just as I did above. So we now are going to have in, pardon me, it's hard to write with one hand, but that works. She's upset, but she'll come back. In first equals 3, in second equals 3, in combine equals 4, and combined equals 50, 40, 30, and 25. Notice something. Think about it. What is in combine? Yes, it's where we are, but does it have another meaning? Here we in combine was 2, we had 2 elements. Here in combine was 3, we had 3 elements. Here combine is 4, we have 4 elements. Looks to me like it's also the number of elements. Well, let's see now. We're going to compare 15 and 25. Now we're going to copy, wait a minute, we used 25. We're going to compare 15 and 20. Copy 20, and again, the in first doesn't change because we didn't use the 15. The in second changes, so it's now 4. The in combine changes, it's now 5. And combined equals 50, 40, 30, 25, and what number was it that I copied in? 20. Well, let's see. We're still going strong. So now we're going to compare the 10 and the 15. So compare the 10 and the 15. Copy the 15. What do we have? In first equals 4. In second equals, didn't move. In combine equals 6. And the combined equals the 50, the 40, the 30, the 25, the 20, and the 15. Now, we have reached a very important point. Look at what in first is. In first is 4. First is 0, 1, 2, 3, and 4. I hope I did that right. Did I copy? Yeah, I think I copied everything right. So there's more in it. But let's look at second. Second is 0, 1, 2, 3. But now, in second, I copied the 15. I made a mistake. Right here, I made my first mistake. Not the last, never is. Get rid of that. Now, I compared 15 and 20, and I moved 20 in. Now I compare, I was right. I compare 15 and 10. I copy the 15. Now I got to be careful. In first is not the one I moved. It remains at 3. In second is the one I moved. It goes to 5. In combined equals 6. And the combined equals 50, 40, 30, 25, 20, and 15. And here's the point I wanted to make. Second has 4 elements in it. I've got this at 5. Now, wait a minute. How can that possibly be? What am I going to do? I'm too high. It's above where I should be. So I've got a problem. There's nothing left to compare in second. So the idea now is, I hope I've done all this right. 0, 1, 2, and 3. I think for some reason that this one was wrong. Yes, it was the 20 that moved. This was a 4, and this was a 3, and now this is a 4. The reason is, the minute we get one of the two to equal how many elements are in it, we can't compare the two of them anymore. I told you she'd be back, and she always is. And this is what she likes. Now, in second, okay, in second equals the num in second, the number of them. There are 4 of them in there, and the 2 are the same. Stop the comparisons. We need to copy the rest of first into combined. Now, the way it's set up, at most one of them can be finished. If there's no. It's possible that the last 2, they were the same size, and the last 2 were the same, and both of them are done. It's also possible that one of them is done, but it's impossible that none of them are done, because otherwise we'd be finished. Both of them would be finished, and we'd be out of it. So, I've caught that in the program here. I've repeated most of this there. And if you look, here's my while loop. It does the 3 cases I had. And then I keep going as long as both of them are less than the number inside their particular array. And then whichever one of them finished, if in first is not num first, in other words, there's something left in first, then move it. Start it in first and keep going as long as you're less than num first. And keep moving them along. Otherwise, if in second does not equal num second, do this. Now, it's not an either or. It might be neither. We might be finished with both of them. So I didn't put an else. I just said check each one. One of them is probably it. Maybe neither. Doesn't matter. There's one step left. I need to count how many I put inside the combined. And that's very simple. Num combined is how many items, elements there are in combined. Now, this is going to be part of the algorithm you need to do for adding 2 polynomials. Again, I have list of integers. You have an array of terms, and your terms are in order by the exponents. So where I'm comparing the elements in the list, you're comparing the exponents. And I had it a little easier when the 2 exponents were the same. You have to do a little more, because if they're the same, you have to add them. And you might end up with nothing left, as I have in one of the examples that I sent to you in the sample run of the homework. That is the problem with the plus. Now, you also have to do, let me get to here. Here's homework 18. You also have to arrange it so I can output directly, as I did, it's further down, pardon me. See here, C out, P2 is put P2. That's a polynomial. P1 is a polynomial. P3 is the sum. It's a polynomial. So instead of the print that we had in the previous homework, you have to overload the chevrons for output. And I suggest that you look at the last video and the last items I put out. I have it right here, the overload notes. There is how to do it, and there's a sample there showing it. So that's what you're going to be using to figure out how to do the overload of the output. The overload of the plus, I did higher up in here. I did one for my case. I would use either one of the first two. I find it more comfortable to use the first method, but you might not. I don't know. But that's what I used when I did mine. So, the program is not massively difficult, but you have to have your wits about you. And you have to look at these examples and understand them. Again, if you don't know how to do it by hand, there's no reason you should be programming it. You have to do an example, as I just did there, to get the feeling for that algorithm. You have to do something like that. And no matter what anybody says, no pointers are necessary for this problem, and I will take off if I see any. The reason is you haven't studied pointers yet in this class in C++, and you really don't know all the details of them. Or maybe you do, and even if you do, you don't need them. They have a lot of overhead, and they're not really necessary here. Now, everything I've done could also have been done instead of an array using a vector. I don't care which method you use, because if you look at my main line over, I guess it's here, I use poly, and it looks to me like I've got get term, or I would have get term up here in what I want you to add as a method of that's 16. I wanted 18. Sorry. There it is. If you look in here, you won't see anything that insists that poly be an array. And if you look up here, all it says is get poly term. That could be either an array or a vector. You don't even, so either one is acceptable, however you did problem 16. That's it for now. I expect tomorrow or Wednesday I will put out the first video on pointers. So we're finally getting to that. See you later.